All right, here goes practice 5, number 5. All right. Gisella's 0.2 kilogram model rocket is observed to rise 100 meters above the ground after launch. What must have been the launch speed of the rocket at the ground if 30 joules of energy were dissipated to air resistance on the way up? Okay, so this one's a little trickier, trying to figure out where your positions are going to be. Okay, so she's going to launch this rocket, and then it's going to end up here. All right, so let's say A is the ground and B is up top. All right, it says it's going to go 100 meters high. Okay, and we're looking for the launch speed at the beginning. All right. Okay, so let's ask ourselves the questions about position A. Is it above the ground? No, because it's launching from the ground level. Is it moving at launch? Yes. Okay, it doesn't mean when it's sitting there. We're talking about after you've lit it or whatever happens to make it take off from the ground. Okay, so it has speed at that point. Any springs? Nope. Any ED? Never at position A. Okay, so the whole entire pi is going to be EK when we start. Okay, so let's do 1/2 mv squared. We've got nothing, nothing, nothing. Okay, so the EK is going to be 1/2. The mass of the rocket is 0.2 kilograms. Okay, and V is what I'm looking for. Okay, so now I run into a problem because I don't know the EK and I don't know the velocity because I don't know the total energy. Okay, so sometimes this happens. If it happens and you're sort of stuck, right, I can't solve this, then I have to go to position B and try that side to see what happens. Okay, so you don't always start at position A. All right, sometimes you have to go to position B. So let's see what we know about position B. Is it above the ground? Yes. Okay. Is it moving? No. All right. When it says maximum height or highest point or something like that, that means it's not moving, right? Because if it was still moving, it would get higher. So it maxes out when the velocity goes to 0, then it'll start falling back towards the earth, okay? No springs, okay? And it says, yes, there's 30 joules of energy dissipated, okay? So no springs, whoops, no speed. All right, so let's see what else we can find here. Let's see if we know enough to find this EG. So I've got 0.2 kilograms, 10 newtons per kilogram, okay, and it says it goes 100 meters in the air. So good, I can solve for this, okay? So 0.2 times 10, 0.2 times 10 times 100, 200, probably could have done that in my head, 200 joules. Okay, so if I had 30 joules were dissipated, nothing and nothing, and 200 of EG, that means my total has to be 230. Okay, so you see how I had to find the total from position B. It's almost all EG, okay, and there's like a little small amount of EE, okay? Almost all EG and a little tiny bit of ED, all right? Okay, so now I can go back over here, and I know that this also must be 230 joules. Okay, so this has to be 230 joules because that's the only energy that there is. Okay, so 1/2 times 0.2 is 0.1. Okay, V squared. Divide both sides by 0.1. Okay, so then I get that my V squared is then going to be 2300. Okay, but I don't want V squared, I want plain V, so I have to take the square root of both sides. Okay, and then I get a velocity of 47, let's just say 48 meters per second. Okay, please make sure you're plugging this in your calculator, not just writing down my answer, because then when the test comes, you're going to be in trouble. Okay, so please plug it in your calculator yourself. Okay. All right, so the tricky thing about this is you had to actually do position B first, which sometimes happens. So as you start to move through and it doesn't seem to be working, just keep going, and eventually you'll figure out where it's supposed to go. Okay, you just got to keep working.